First of all, I'm impressed that all of you came out of the sun for neuroscientists, but not just any neuroscientist. So we are, I think, very lucky. First, thank you, Craig. We're at our president's house, and thank you for hosting us again. And Antonio Damasio, I must say, is very special, at least to me, but I think to many, in more ways than one. First of all, I think we are friends. And Professor Damasio and Madame Damasio is also professor. Hannah is here. And amazingly enough, work together. So this is a true union in every way. And we're lucky to have both of them here. Antonio has many things going for him. One, he comes from the old world. He comes from Portugal, great empire that then disappeared, and now he is he's here at sort of a floating empire, and he's the head of the Brain and Creativity Center at USC. He's a neuroscientist, but he's also a philosopher, and what I find so interesting, and the reason why we at the Institute do a lot of work together, and we're grateful for the work that we've done together and will continue, is that he thinks, obviously as a scientist, but he also thinks as a human. And the book that Antonio just wrote, and I didn't know this, but we have become a store, so you can buy his book, in the dining room. But the book, The Strange Order of Things, really addresses not only in many ways where we come from as humans biologically, but also puts it in context to some of the big issues that I think are the issues that we're excited about and also scared about, meaning are we just algorithms? Are we just, sort of a supercomputer? And what is the relationship between biology and what we think of as basically machines? And I think that's part of what interests me when we get together, but it's something that Professor Damasio has thought about a lot. And therefore, tonight, we're going to have an interesting conversation, I hope, between Craig and Antonio, but then any of you, if you have very, very sharp questions, raise your hand. But thank you, and thank you for being here.
Thanks, Nicholas, for that lovely introduction. Let me add just a few things to it. First, adding to the introduction of Antonio as representing not only the Portuguese Empire, but a range of intellectual fields that he's brought together. One of the remarkable things of reading this book, as others of Antonio's books, is that he is grounded in experimental science, in very serious research, in evolutionary theory, and he is reaching out and connecting this to a range of other disciplines, other intellectual perspectives, and he is thinking both about the implications of the most basic scientific work and about the things that we don't yet know for sure based on scientific work, where the beginnings of conjectures, the beginnings of new ideas come together. He is also remarkable for his ability to write clearly about serious scientific subjects. So I make this a recommendation to all of you to buy books at Nicholas' store. I want to assure you that this is not from the profit motive. Neither Nicholas nor I reap any benefit from the sale of the books, but the books are worth buying and worth reading. Antonio is indeed at the University of Southern California as the David Dornsife Professor of Neuroscience, Psychology, and Philosophy, and has, as Nicholas suggested, worked in complementarity and collaboration with Hannah Damasio on a range of projects. And her work on brain imaging and scans is a complement to his. Antonio has, with Hannah, created the Brain and Creativity Institute. Now, many of you will have been able to benefit from this in various ways, including buying the book, but the jazz concerts, the classical music concerts, the exploration of the brain science of music, the exploration of the interface of acoustics, the physics, the engineering of the context, and the processing of sound. That is part of the research, but also part of the public service of the Institute, which reaches out to the community. And if you get an invitation, if you're fortunate enough, you should definitely go, because there are wonderful programs at the Brain and Creativity Institute. Well, Antonio's published a very large and influential corpus of work. He's been rightly recognized by a variety of honors and prizes, a fellow of multiple academies. He's a fellow, of course, of the Academy of Medicine, but of many others, the European Academy, the Beaumont Medal of the American Medical Association, perhaps the most distinguished, the Prince of Asturias Award. He is one of an international elite of leading scientists, and we're lucky to have him in Los Angeles, have him as a friend to the Berggruen Institute, and have him here tonight. The order of running for tonight, Nicholas foreshadowed, will be that Antonio gives you a brief introduction to The Strange Order of Things, to this book, and it's an introduction to the title, What is the Strange Order, but also to the subtitle, because part of what's remarkable about this book is that it reaches from the very questions of the nature and earliest history of life to culture and supraorganismic development through the theme of feeling, which is integral to the book. So Antonio will give us an introduction and outline the book. I'll ask Antonio a few questions, and we'll have a bit of an exchange about some core themes, and then we'll open this up to all of your questions. Antonio.
Thank you. It's a great pleasure to be here. Thank you, Nicholas, for your very kind introduction. Thank you, Craig. We are indeed colleagues and friends, and we've been very supportive of the idea of the Berggruen Institute from the start, and we're delighted that we have the Berggruen Institute here in Los Angeles, and that it's definitely a very important addition to the cultural life of this city. So, straight on to the book. We'll have a conversation, and then if you have burning questions, and if we have time, I'd be delighted to answer them. So there are two things to begin. This strange title, The Strange Order of Things, and people will want to know what this is all about. And of course, you need to know that it was not the original title, but it's a title that sort of imposed itself once I was reflecting on what I had written. The subtitle, on the other hand, is fundamentally what I always wanted it to be. The original subtitle, or maybe even the title, was Homeostasis, Feeling, and the Making of Cultures. And then, since homeostasis is a rather unpalatable word, it ended up being life, because it's a very good substitute to begin with. The idea is the following, where I started. When you think about biological accounts of cultures, or even forget about the biology, and you just try to think in plain psychological terms about how is it that cultures came to be. And when I talk about cultures, I'm talking about a series of instruments and practices that include, and I'm going to give you a very sharp order of these things, or a listing. You can mix and match. Let's include the arts. Let's include religious beliefs, moral systems, philosophical systems of inquiry, governance in general, including the instruments of economics, and technology and science. This is a sort of a basic listing, and in this listing you would fit practically everything that we hold as very, very important in the world of cultural development ever since the beginning of what you could call human cultures. So when you think about this, almost always, and you can find this from all sorts of accounts, written or the accounts that you can get just by questioning your friends. You ask them, how did this come about? What do you think was the important thing? Why did humans develop this spectacular collection of practices and instruments when animals did not, non-humans did not, or if they did it to a very restricted rate, very restricted amount. And the invariable answer is that, well, of course, we are prodigiously smart, we humans. We're very smart. We have ways of reasoning that are different from all the other species. We have this spectacular thing, which is our language. And thanks to our language, of course, we amplified the abilities that good intellect gave us. We have sociality, and it's a sociality that is of greater intensity than those of other creatures. So you put that story together, and that's how you explain grossly the onset of cultures and the blossoming of cultures in humans. And I think that this story is both very correct and very incomplete. Of course, it's without a question that without knowledge, without reason, without the spectacle of languages, without this incredible sociality that we have had and that we have by our biological makeup and that we have actually increased, of course, you couldn't have cultures without all that, no question. But the issue is what is missing. What is the very blatant thing that is missing, and it's there in the room asking to be called and to be told, look, you were important. And that is feeling. Feeling as, when I talk about feeling, just think about suffering and pain, and think about the very opposite of the spectrum, the possibility of flourishing and pleasure. And just think about how those, even if you would just restrict yourself to those polar opposites of the feeling range, you would have the prime motivators of anything you can imagine culturally. And, you know, sometimes people will say, well, you know, we invented cultures because we needed to survive. And I would say, really? Sure, you needed to survive, but why did you know that we needed to survive? How did you know that survival was important? Well, you knew that survival was important because you felt impending death, disease, sickening. You were very aware of the very opposite of that, especially when you are in pain or suffering, the fact that there is pleasure either already felt or prospected. And so I think that there is a critical element that normally is missing from the accounts that we give of cultures. And that's something that is developed in the book. Then there's something that is even more important to me, and that's the next element. And it really has to do with life itself and with the process of homeostasis. Now, here the issue is this, is that feeling, and I'm going to make a long story short, that I explain why this is so in the book. Feeling is actually a sentinel and a representative, a deputy of the process of homeostasis. So I will submit the following to you. When you feel pain or suffering, or when you feel very well and happy, and here you are with this marvelous view, this great house, these friends and good colleagues, when you feel that, you're getting a message very clearly from your fundamental life systems that the system of life is either operating within a conducive range to the continuation of life, or something is very much the trouble, very much a problem, and needs to be corrected. So think of feelings as the representatives of homeostasis and as the announcers of the fact that the process is either going very well and you're going to survive, or the process is actually veering from the kind of steady state that is compatible with life and is in fact threatening your life. And it's threatening your life, first of all, by removing your well-being, and it's giving you a possibility of knowing about it. So feeling and homeostasis and the regulation of life then become perfectly coupled in terms of the history of evolution, and that's one of the things that is probably the main theme of the book. Now, something also very interesting happens at that point, is that you start asking yourself about when did this homeostatic operation start? And you really are pushed down to the very beginnings of life on Earth. So in the very least, you're pushed down to about 3.9 billion years, which is a fairly good amount of time, considerably less time than the Big Bang, but quite a lot of time. And what you're confronting when you look at that epoch is the appearance of the first unicellular organisms that were fully organized, had a membrane, had a possibility of having a capacity to sense and respond, and had a capacity to organize life in a very complex way, but to us it looks very simple. There was no nucleus and there was no nervous system in those creatures. But then you discover something quite spectacular, is that those creatures, I'm now talking about bacteria, were in fact capable of some cultural life. And I'll give you some examples, which sounds a little bit scandalous, but here goes. Bacteria, first of all, have an intense social life. You may say, well, don't call that culture, but wait a second. There's a very intense social life. The following things happen that are quite extraordinary. If bacteria are in a terrain that has all sorts of nutrients, and life can be good, and the exchanges with the environment can really operate well, what happens is that bacteria actually segregate and maintain a certain degree of individuality. But if you are in a territory where there's a threat, either because their lack of nutrients or because there's actually a threat from an organism or from physical conditions. For example, bacteria in your throat and your doctor prescribes an antibiotic and the bacteria are clearly very threatened. Then they will band together and they will create a biofilm, and they actually create a palisade of defense against the attacks. So what you're really confronted with is the fact that in spite of having creatures that do not have a mind, and they don't have a mind for a very good reason, they do not have a nervous system. They don't even have a nucleus. And yet they are able to cooperate or create a conflict with others, and they're even able, and you can read that in the book, they're even able to make quote-unquote judgments about those in the group that are either cooperating with them or not, and they can even distinguish because they have surface molecules on their membranes that can even allow them to distinguish between kin and non-kin, and guess what? They are even capable of preferring non-kin, provided that non-kin is on their side of a fight, than kin who sort of veers away and becomes a traitor. So all of these things that we consider very much a part of certain aspects of our culture, for example, and that we recognize in many other complex species, were in fact present in bacteria and are present today in bacteria. What do they have? What's the equipment with which they're doing this? Again, no nervous system, no nucleus, but they have the physics and chemistry that are necessary to engage in this homeostatic process, whereby they, as an open system, gather elements from the surround that can provide energy, and they have the chemical processes, the biochemical processes that allow them to transform the sources of energy into real energy that maintains the machine going. And something which is very important, and I'm almost done, promise you, something is very important is that when they do that, they engage in what truly is a process of metabolism, which is a fundamental aspect of our lives. Metabolism, by the way, is a very opaque word. It doesn't really tell you, it doesn't suggest what is going on. But if you take the German word Stoffwechsel, I immediately pointed into the fact that we're dealing with an exchange here, and that's really what it's all about. There's an exchange of materials that goes across membranes and that allows the process to be going. And what that process of homeostasis, which is obviously based on metabolism, is doing is maintaining life against the odds that are really contrary to maintaining life. As we have Sean Carroll here, who will tell you about the second law of thermodynamics, and you keep the system closed and without having those exchanges, and the system will quietly go into its entropy and will come to a standstill. And that's exactly what we don't want. We don't want that process of that point of thermodynamic equilibrium. What you want in life is this very curious thing, which is a way of automatically choosing one steady state that can allow the machine to go. And the best of the steady states are the ones that allow you to, after all the exchanges of energy are settled, to have a little bit of surplus at the end. If you have that surplus, you actually have energy for a rainy day. And this is actually not, it's a little bit difficult to conceive this at first, but you realize, why should homeostasis aim at having more energy constantly than what it needs? And the answer is very curious. It has to do with stress. If you have an organism, imagine yourselves, and you are very thin, and you have not been eating well, and you are sick. You go into stress, and your risk of getting really sick and dying is much higher if you don't have some reserves. That's exactly the way nature has been operating in terms of life from the get-go. You have a little bit more than what you need. I think this is actually very interesting if you project this into the world of economics, because when you think about surpluses, that's exactly what it is. It's a very natural thing to have surpluses. So that's good, so that people who are rich can get richer, but profit is maybe a little pushing too much. We can discuss profit. Okay, fine. Let me just finish then my story. Strange order of things. Why is it strange? It's strange because you would normally not imagine unicellular organisms developing this kind of equipment for a quote-unquote cultural life, and even for something that the best way we can describe it is a moral attitude. So this is complex, but this is there with very, very simple life. It's a characteristic of life. It's not a characteristic of complex systems such as we are, or such as monkeys or elephants are as well. The other point is this: in the sequence of events, what you find, so we are at 3.9 billion years ago. When do cells with nuclei appeared? Well, 2 billion years ago. So just imagine, it's really quite beautiful when you think that you have to go a couple of billion years in the history of life for cells with nuclei, eukaryotes, to appear. It takes a long time to develop these things. And then when do we really get to multicellular organisms? Well, that's about 600 million years ago. Just look at this. You go for a long, long period with very simple systems, and it takes, it's quite recent, in fact, the development of a system such as the nervous system, by which time we already had the equivalent of an endocrine system, of an immune system, and circulation. All of these things were operating. But it's by the time you get this multicellularity with nervous systems that you acquire something completely new, which is the ability to integrate and coordinate the system such that, in fact, it can grow and can get, can be larger. Because until that point, it was extremely difficult to coordinate all of this. Once you get the possibility of a nervous system, the first thing is that the system can go larger, and you can make sure that something that needs to be coordinated, down a tentacle of a squid or down a leg can be still operating under the control of the nervous system, even if still, by that time, the control is not intentional, the control is not mindful, the control is obviously not conscious. And then once you get nervous systems, you get something new that was not in the plan, for the simple reason that there was no plan, and that is that you can begin making maps of other things in a nervous system. Maps of the interior, maps of what is around, and once you start making maps, you get the beginning of access into what becomes images. images of touch, images of what you see, once you have eyes to see, or what you hear, or what you smell, or what you taste. And all that imaging is going to be the entry into the world of the mind as we know it, and is going to be the entry into the world of feeling, because feelings are nothing more than the multidimensional representation of the states of our bodies, or states of life in the interior. And they have a valence exactly because the life can be running well or running not so well. And then you enter that world of the mind that in fact projects itself into what it is today. So the strange order here is that you start, contrary to what you might expect, you start at a very complex level already, where you have a life that is not just a stupid little life of bacteria that don't do things that are interesting. They act interestingly. To the best of our knowledge, they don't know that they're acting. They have intentions that are not their intentions, they're nature's intentions on these organisms. Once you get access to image making, you start getting the possibility of representing your interior and the outside. And once you get that, you get the first access to the possibility of representing the state of homeostasis as feeling. And that opens up the flood. And then you can have minds in a more complex way. You can develop all your cognitive capacities. Once you have feeling, you have access to consciousness, because you cannot have feeling without consciousness. It's an absurdity. You know, when you say, or when an animal doesn't say, but complains of pain, which animals can do, that complaint, yours or the animal's, can only come to you or to the animal because you know that it is happening, because you have subjectivity to have that. If you didn't have subjectivity, which is the fundamental ingredient of consciousness, you wouldn't know. You know, so these two things emerge at the same time, consciousness and feeling. And of course, bacteria clearly do not have that, to the best of our knowledge. And once you have that and you have language, then you have possibilities that are really extraordinary. And so I'm trying to make our human life and our achievements a little bit more modest in proportion, or maybe not so much make our achievements more modest, but rather make the achievements of other creatures less modest, because they clearly are very important components in the story that we are telling. And we can talk about many of the things that are interesting in terms of the development, in terms of the first trigger of how you would develop an instrument of culture. I'd like to give the example of medicine. And it's not just because we were trained as physicians, but just think of this. Imagine the first patient that appeared in the history of humanity, quote unquote, and the patient going to the first physician, and the patient very likely was complaining about something, or you would not go to the doctor. And there was a complaint, suppose pain, you know, a fracture, or some malady that made the patient go to a doctor. What does the doctor do? Well, the very first doctors confronted the complaint that is in fact born out of feeling. If you didn't have feeling systems, you would not know that you were sick, and tried to alleviate that with some kind of remedy, in all likelihood a very primitive remedy. Now, something very interesting comes next. How did this patient, and you too, all of us when we are sick, how do you know that the medicine works? You know that the medicine works because there is a change in your feeling state. So it's not just that feelings are remarkable motivators, alert systems and motivators for action, which they are clearly, but that feelings are also the arbiters of what comes next. Feelings are monitors, and feelings are telling us that either the medicine worked or did not. And so that process is absolutely critical. And when it comes to cultural selection, that's exactly critical, because we select in cultural selection, as opposed to biological selection, we select features or instruments or practices if they work. And if they don't work, we don't. So feeling continues to be important there, and this would be for discussion with Craig or with others. Feelings also are critical as negotiators of the process. You know, when we invent a law, when we have a certain aspect of governance, for example, or when we have a certain aspect of a moral rule, feelings were not only motivators of that invention that came by way of our knowledge and reason, but they were also clearly arbiters for the possible selection or rejection, and they become critical in the negotiation. It's so interesting that take the current political process, when people are constantly talking about the process as an intellectual process. And actually when feeling comes into it, it generally comes with a reference to emotion, and it's generally a very provincial reference to emotion, because when people refer to emotions in our culture, which is extremely biased against emotions, it tends to be to denigrate emotions and say, "Well, don't be so emotional, you know, use reason, come on, be a man." And it's very interesting because that just shows an incredibly narrow view of the panoply of emotions and ensuing feelings. You know, there are, of course, very bad emotions. You know, I like to say that, for example, anger and rage are emotions that have outdone their usefulness in our cultures. You know, we have to keep them because otherwise we would probably die. But in fact, they are overused and very unnecessary, but they were installed very clearly along evolution, and they have actually gained enormous magnitude in primates, which is the reason why we've inherited them in spades. But then think of all the good emotions that people don't think about. Instead of thinking about anger or envy, think about compassion and gratitude, and the sense of benevolence that comes when you have really good social fellowship. So there are all sorts of positive emotions that have an enormous nourishing and important effect in cultures. And it is not true that you're going to be a better reasoner and you're going to come up with better results in, say, a political or social negotiation if you are just thinking in terms of the facts, of knowledge and of reason. On the contrary, you need all sorts of your emotional tool in order to be able to reach some kind of accommodation. So there too, emotions are operating in spades. So this gives you a sort of general idea. The critical words here are homeostasis as the word and the concept that capture the arrangement of life systems from very early on, and that continues to operate, and that in fact, at our level, once you have a culture, are operating to create something that I like to call socio-cultural homeostasis. So the system was there all along. It had as the intent, quote unquote, maintain life in the best possible ways for individuals and for a social community. But by the time we begin to have a say in this, because we have feelings and because we have knowledge, we then can start having a say on what happens with the instruments that we invented in the culture and how they should operate. So by that time, you have a partnership between the natural systems of homeostasis and the ones that are being driven by this combination of feeling and intellect, which characterizes the best of humanity and very often the worst of humanity as well, because it can go both ways. So I will stop right here.
Okay, thanks. Okay, Antonio's presented a remarkable condensation, and we had thought of giving the exam on the course right now. But in fact, we want to draw you into this a bit further and send you home to read more before the exam. So let's try to do that. But let me pull at a few threads in the discussion, raise a couple of other issues. Start with the title, The Strange Order of Life. You said, well, it's the strange order because...
Things.
Hmm?
Strange order of things.
Strange order of things, sorry. It's the strange order of things because it goes back so far and it's bacteria, and who would have suspected it, right? So one of the messages we're getting is of a very ancient origin of order. But would it also be right to say it's because strange order does not depend on intention of interactance, does not depend on consciousness. It results, in the bacteria example, from cooperation without consciousness. Yes?
Yes, I would say absolutely yes. You know, it's really astonishing when you think, which, by the way, is one reason. You know, there's now a trend which I think is a bit unfortunate, and I don't think it's going to triumph. Some people led by, and this especially comes from philosophy of mind, led by the difficulties in what I like to call the consciousness wars. You know, there's been a tremendous amount of fighting within the camps that try to interpret the phenomenon of consciousness. It has many reasons. One of them is that people poorly define what they're talking about, and so the concept is too wide, and people really don't know what they're talking about when they're arguing for one or another position of consciousness. But then, as a result of that, people are hiding in some extraordinary things, like, for example, panpsychism. And people are saying, well, everything's going to be conscious. Maybe stones are conscious too. And of course, when you go that way, you're not going to end up very well, because there's no reason why you should go to those extremes. You know, you can perfectly well have a very strong hypothesis based on facts and say, look, if you have nervous systems, given the fact that consciousness requires a process of subjectivity, and that subjectivity can only be achieved by a combination of having a certain frame of your organism and feelingness for the images that you are experiencing. Given that, it's pretty unlikely that bacteria can have consciousness, because they just don't have the tools to do it. They have lovely chemical molecules floating around in very nice biochemical circuits, and that can be very complex and very beautiful, but it doesn't mean that they have the armamentarium to do imaging and to the combination of imaging and to create the spectacular integrated image. I'm now seeing all of you guys in a great cinerama sweep.
Antonio is conscious of us.
And I'm very conscious of you. And I'm also very conscious of me. You know, I haven't had dinner yet. And so I'm very and I didn't have drinks or snacks, because it's bad form to have drinks or snacks before you talk.
Morals.
Exactly. A very good moral injunction. This comes from the Hammurabi Code. And so this stuff really needs a nervous system. And so it's really amazing that you have bacteria and many other creatures after that don't have this and do spectacular things. When you go with insects, it's slightly different. So, you know, actually, I give pride of place in the book to bacteria, because they're really horrendously bizarre. But when you go to social insects, that's 2% of all species of insects. And they have existed for about 100 million years, okay? Yeah, fair amount of time. But guess what? Those 2% of social insects, like wasps, bees, ants, which are in fact very social, and there the word social is very, very appropriate. Those little animals actually have nervous systems, and their nervous systems are actually not that unlike ours. They have exactly the same schema of the brainstem. They have a lot of the same molecules we have. They have a lot of the same neurotransmitters, and I'll bet you $1 that they have feelings.
Let's ask them.
Yeah, exactly.
Are they conscious?
Okay.
Yes.
Yes, they're
Oh, yes.
conscious.
Oh,
Great.
yeah.
So
No,
I was trying to bring us along. This is the point. So the stones are not self-organizing, right? There isn't cooperation among stones, so far as we know. There is cooperation of a kind with the bacteria, right? but it doesn't depend on consciousness or intention, right? Antonio alluded to nature's intention, but we won't go down the path of that, whether it's metaphor or not. But it doesn't depend on the intention of the bacteria, right? And some of this, I want to get us to the hard consciousness questions eventually, but don't go there immediately yet. Some of this depends on the development of neurons and neural systems. So you may have thought this was all neuroscience, but the start of the story is before there's anything to have a neuroscience about, right? Exactly. It is about the early evolution of life, driven by the imperative to homeostasis and feelings as the regulators of response, you know? Okay, and so some of that lives on. This is where I wanted to get us to, right? Because one of the themes that I thought was interesting is you point out that while there is all this exciting news that comes with the rise of neurons and neural surveillance, and effectively neural surveillance allows for a more complex relationship, integrating the complex systems of the body, eventually having subjective awareness and consciousness, right? This chemical action doesn't stop. It's not the case that the earlier development of a more direct action goes away. It remains a part of our makeup. How does this matter?
Yeah, it matters because the system of life regulation, and in fact very often precisely with the same molecules, has been conserved. So we really keep, and you know, keep in mind that what nature has been doing to sort of nestings and increase in the size of systems by using repetitions. For example, the birth of eukaryotes, which happens about 2 billion years ago. So when you have a cell, a unicellular organism that now has a nucleus. You know how this was achieved? This was achieved, according, for example, to Lynn Margulis, who was a great scientist, and unfortunately dead by now. What Lynn thought, and there's pretty good evidence for that, is that if you take two bacteria, neither with a nucleus, but one bigger and one smaller, there was a time in which one actually took over the other and incorporated it in that same organism. And the smaller bacterium became the nucleus of the big bacterium. So you really took two things of the same kind, but of different sizes, and you married the two together, and you ended up with a system that is brilliant, because now you can concentrate nucleic acids and therefore systems of coding inside that nucleus and both run the genetic system as well as the housekeeping system of that cell from that nucleus. And this is a huge step forward. So it's this kind of combination. And later on, you know, what happens with us multicellular creatures is that we have been incorporating more and more cells and differentiating them in tissues so that we have this huge amount of cellularity. But keep in mind that every cell in your organism, whether it's cells in the heart or in the lungs or in the skin or in the gut, have in fact exactly the same principles of operation as those of a bacterium or of an amoeba. And they are all, each and every one, subject to the imperatives of homeostasis and of failure if those imperatives are not met. In other words, we are all of this cellularity is at risk. It's not just one cell that is at risk, it's all of them in all of these tissues. And even more, which is interesting to give the final response to Craig, is that inside our guts, there are actually more cells in the form of bacteria than the total number of cells that we could consider human but non-bacterial. So you have more trillions of cells in the gut and the bacteria that are there to do a highly cooperative job, because we normally think of bacteria as things that are going to attack us and that need to be treated with antibiotics, but the majority of them are not that way. We have sets of bacteria everywhere in our skins, everywhere in our different organs, and in spades in the gut. And they are actually doing a job for us. They're permitting certain things that are necessary for our own metabolism. So that game of cooperativity that starts early among bacteria is actually now being played with bacteria in relation to large creatures such as us and all mammals that are known.
And part of this is played out in direct chemical action, and part of it through neural surveillance and some kind of mental mediation at some levels in the system, which is part of what leads some people to want to draw this thinking versus the animals kind of distinction, the essence of this. But what you're telling us is that it's still feeling, even when that drives the system, even when there is a mental mediation between feeling and response.
Correct. Yeah, so the principles remain the same, and it's still the game is very much conserved. It's a game of promoting life,
right,
come what may, and it's very it's very simple at the level of bacteria. It's extremely complex in very complex organisms, and it's incredibly complex with us because now we have all of these systems that are in fact cultural projections of the fundamental basic non-thinking systems.
So let me pull out a couple of more things for you to comment on. One implication of this, again, in the it's not just neuroscience narrowly understood vein, is it's crucial that we're not thinking just of brains. We're thinking of nervous systems and the bodies of which the nervous systems are a part, and indeed even interorganismic relations all the time.
Absolutely.
And we get it wrong if we imagine that the brain in isolation is the seat of all of the processing.
And that's a very important point, Craig. So what we have, and this is something we, both in neuroscience and in general biology, and certainly in, for example, in engineering, where obviously people have used principles that come from neuroscience, there's this idea that, for example, you can have an artificial system that is going to be conceived in, say, Boolean algebra terms, and conceived along the lines of what Warren McCulloch and Walter Pitts imagine. In other words, we have neurons. Neurons have, axons and synapses. Synapses fire, and if they fire, that's, a 1, and if they don't fire, it's a 0, and you have this digital system. That's where, between Turing and McCulloch-Pitts, that's the source of a lot of what is done today still in those engineering systems. And so the idea is very interesting. So we went from biology to mathematics and to biology crossed with mathematics, and then that came back to biology and especially to neuroscience so that people look at the brain as a digital system only. Well, this is so false that it makes you sick because the majority of neurons in the spinal cord and in the brain stem and in a good part of the nuclei of the telencephalon are actually not working according to synaptic transmission. So what you have is that instead of, especially with neurons that don't have myelin, those neurons are subject to all the influences of the chemistry in the extracellular space. So if you want to model this as a system that is going to be on or off, you have a lot of trouble making the prediction of whether it's going to be on or off, because it's going to depend on the bath that is around it, which is a bath of neuromodulators. And now, the most spectacular thing, which is not in the book, it's alluded to, but it's not there because this obviously was written finished a year and a half ago, so it's not there yet, is that when you look at the spinal ganglia, so if you look at your spine and your spinal cord, you have at every vertebrae level, you have a ganglion, and that ganglion it has the cell bodies, the neuron cell bodies for the segment of the nerve that is in the periphery, can be in your skin or in your foot, whatever, and the part of the neuron that goes inside the nervous system. Well, it so happens that the cell bodies are all bunched together. Imagine a bunch of flowers that you would put together. And there you have all the flowers, and there you have all the cell bodies. Now, guess what? All around those cell bodies, there is no blood-brain barrier. There are 3 points in the brain where the blood-brain barrier is missing. And the blood-brain barrier is really a barrier, is a border that does not allow the blood to freely circulate within nervous cells so that there's no direct influence. But there's a point in the brain stem And there's a point in the upper brain, the telencephalon, and now this, which nobody knew about, so that every level is exposed to what is going on in the capillaries of the blood. It almost looks like a kidney, and it looks like glomeruli. So imagine that you have a cut, or you have a fracture, and you are going to have all these signals that are going to signify pain for your nervous system. But now imagine that you have been taking something. Suppose you had a lot of wine. Suppose you had you were completely drunk on scotch. And at that point, you would actually get much less pain because of the scotch that you had been drinking, not because of the way it acted on the central nervous system, but because of the way it acted on the periphery via your own body. And of course, this is a kind of incestuous relationship that has existed from the start, because when the nervous system developed, it was all like this. So the early nervous systems of early creatures were in fact operating non-synaptically, and it's only very late in the game that you get cortical systems that operate on a synaptic principle. What this means in terms, for example, of AI, is that one reason why the enormous successes of AI have been in the area of fine games, like, say, chess or Go, is because that's where you need to have incredible precision, and you don't want to have many vagaries. And you can model that very well on the model of a synaptic system. And that will continue to grow, and the machines and the robots that use that are going to become ever more smart. On the other hand, to model something that would look like human feeling, that's going to be a different story.
So we just got, if you weren't following, the answer to Nicholas's question, are we just algorithms? And the answer is no.
No.
Okay.
Not just.
And and getting this by way of recognizing the complexity of the system, which includes the body and not only the neural system. But you take this in the book to one more reflection. I'm just going to ask one more question, then we'll open this up. So you also take up David Chalmers' hard question of consciousness, the question of self and reflexivity in this. So say a little bit about how you see consciousness and the role of self-awareness in consciousness.
The hard problem, Chalmers, following many other people, invented this formula of the hard problem. Actually, Galen Strawson, another philosopher of mind, claims that he was the one that did the hard problem. There's going to be a war on, yeah. And so what's the hard problem? Chalmers will say you have lots of problems that are, important but easy to solve, such as, for example, how we move, how we create memory, how we take care of language, and so forth. And those, of course, are important problems, but they have largely been solved in the generality at neuroscientific level and cognitive level, certainly. And then with the consciousness, which I think has already been solved by several people, including ourselves, he says, no, this is very mysterious, and we have absolutely no way of knowing how we have a mental experience, how we feel or why we feel. And this is the thing that really gets to me. It's quite interesting because we had a debate in New York, and I was invited to debate him, and people, it was completely sold out because people thought that there's going to be evisceration, mutual. And I went first, it was my lot, I went first, and I told him that I thought the problem was solvable, and that there's one very good reason behind feeling is that nature and life require it. It's something that was selected because it was so good to maintain life systems and to maintain homeostasis. So you don't need to look for abstruse explanations. It's there, has to be there. And that, of course, feeling is what provides what I call the component of feelingness in subjectivity. And it's critical to have subjectivity, and to have subjectivity you simply have to have a possibility of placing yourself, no matter how subtly, as a subject of what is going on at any given moment. So right now you're listening to me and I'm looking at you, and I know it's me doing the looking at you and you are doing the listening and looking at me. You know, even if you're not paying attention to that self process, you know that it's you. You're not going to think that it's Craig that is doing your seeing and your consciousness of the moment. And how you do that, I think, and that's something that is debatable, is actually by the relentless process of imaging and the relentless process of generating narratives to ourselves. We're born storytellers, and we're constantly telling stories to ourselves. Some of the stories, we tell them in images that are not verbal. Some we tell them in images that represent words in whatever language we're thinking or operating. But one of the things that we image is our own body. And we image our own body at the level of the interior, because we have this old system of the body that, in fact, we've inherited all the way down from bacteria. And we have a more modern, or not so old, system, as I call it in the book, which is actually made of the musculoskeletal frame. So we have a musculoskeletal frame. It sort of gives us the phantom of our body. And guess what? It's being represented in your brain at the same moment that you're representing auditory or visual images from the outside world, at the same time that you're representing images from your gut or your heart. It's all there in parallel panels. So you have a way of joining in the same frame images of the frame of your body, your phantom, images of the state of your interior, which gives you the feelingness, and images of the outside world, which normally are the ones that occupy most of the attention in your conscious space. So you really have this coexistence of imaging, but you don't need to resort to panpsychism or something very strange to do this. You can do it with the tools of science that we already have. It's just a question of being able to think through it and not ignore that there are these different compartments. There's one more thing which is very telling and critical to understand this. Think of the head. We have in the head eyes. Let's just think of vision. When you are seeing, so if I look at you, for example, which I have been doing for quite a while. So it's always very important to concentrate on one person as you speak. So I am looking at you. If I now turn around and I see Stephen Levine there, what I did is not just to change the visual image that is being projected in the retina, but I changed many other things. For example, I moved my head. I moved part of my torso. And then I had all sorts of very complex movements that happen inside my eyes that had to do with the musculature of the eye, because the eyes had to rotate, had to do with the adjustment that I had to do in the lens in order to move from relatively close to further away image. And so all of those processes are really not on the process of seeing, but the process of looking. The process of looking is actually giving you all this imagery that is parallel to the process of looking and is situating the image that is in primary vision within the context of all this movement that was necessary to look. And we do this in relation to hearing as well, and of course very easily in relation to touch. So it's completely idiotic to think that in order to have visual consciousness, you have to rely on what's going on in the retina and the visual cortices. Not true. You rely on many other things. Final point to get you the beauty of this. The control of all this looking system is actually in the frontal lobe, in the frontal cortices, laterally located. So think of the beauty of this. You see with your retinas and with visual cortices that are at the back of the brain in the occipital cortex, but you actually have the process of looking using systems that are on the lateral frontal cortex and the motor cortex. And all of this is being represented in these separate locales, but can be then integrated by circuits that bring it all together in time, though not in space. You don't need to put it all in the same space. You need to put it all in the same time so that it can be coordinated. So it's not mystery. Hard, yes, it's hard, but it can be done.
This is why you've heard nothing from David Chalmers lately. But it also signals, perhaps, we can only hope, a new book that will have the issues of images, narrativity, and subjectivity, not just sort of at the end and beginning to tantalize us, but at those core features of the book.
Let's do it.
Okay, ask some questions to push this along. Tobias, then we go back here. Okay. Okay.
Thank you. Actually, I was going to ask something specific, but your conversation makes me trigger another question. So the question I had in mind was that I wanted to ask you if you think that the hyper-calculative or algorithmic AI that we have right now, or the dream of AGI, artificial general intelligence, would, from the perspective of your book, be actually a severe case of psychiatric illness, precisely because it's hyper-rational and calculative and not integrated with emotions. But I think that this question asked in the abstract misses one important subtext of the book that you touched on in passing, but not really. So if I would ask a question, I would say, so here is a summary of your book in a few words. It's an anti-humanistic humanism. This will sound strange, but I think one important feature of your book is that classically we humans think of ourselves as much more than mere nature, mere animal, let alone more than mere bacteria. But one thing that you show is that the basic features of living systems that are sufficient, or maybe not sufficient, but almost sufficient to also describe humans can already be found in bacteria. So you actually nivellate the difference between bacteria and humans at the beginning. And then you develop very gradually a language of describing humans in naturalistic terms, right? And this has many levels. So whether this is quorum-sensing molecules that we find in bacteria when they organize their social life, so they issue little bacteria, and then they issue little molecules in bacteria that live independent, suddenly come together and have a feast, a party. There are cheaters in there. It's very impressive to see this in a video. And exactly these molecules are released in our gut and can function as precursors to neurotransmitters that we find in our brains. And just so happens that these neurotransmitters in our brains are centrally involved in our social life and organizing social life. So this is so wild. A language and a molecule that is issued by bacteria, that is sufficient to describe social life in bacteria, can be used to describe human social life. So this big difference, we humans are so much more than mere nature, and let alone, bacteria, suddenly falls apart. And to hammer home how big that is, recently, after I gave a talk on bacteria, a philosopher said to me, well, that's a classical case of overselling microbiology. What would be the importance of bacteria for the human mind? And the way he said mind was, full of vibrato in his voice. And little did he know how much he lives off his bacteria. But based on that system, sort of on this capacity to describe the human in a language that is actually not invented to describe humans specifically, you bring the human into view as imbricated in this strange order of things. So this brings me back to psychiatry. So can forms of intelligence exist that are not imbricated in this strange order of things, that are kind of exempted from it, that are not social, that are not emotional, that do not have homeostasis? Because that's the dream of AGI, of artificial intelligence. And reading your book, I'm left with this impression of Kurt Goldstein's patients who can no longer express feelings and who are severe cases for psychiatry.
Yeah, this it's very interesting. You ask first of all, you make a lot of very important points. One very important point is that you say you gradually come into the humanist view, which is absolutely correct. And I want to say something which I say 2 or 3 times in the book because it's so important. It's very easy to look at a book like this or look at this discussion and say, oh my God, this is really about not considering the human for what the human is. This is downgrading the human to the level not just of non-human species, but come on, to bacteria. That's really taking the cake. And clearly it is not, and what I would say is that I would defend the enormous importance of life systems in general, no matter if they're 1 cell or a billion cells. So that's the very first point. The other is that you cannot rely on our traditional humanism to decide on what is so important humanly. And I have ways of dealing with that issue because there is nothing in what we're saying about other living systems that interferes with the main reason why humans have their dignity. And I'd say that the critical issue is this. If you want to be fully human, you have to respect what happens in a human being who has the access to a whole life of memories and a whole life of anticipation of mental states and of events. So we all create memories of everything that we have lived so far, episodic memories that describe our lives with all their good parts and bad parts, but we also at the same time generating something, and this is something that very, very few animals, if any, other than humans will have. It's possible that elephants, for example, or some sea mammals have something of that kind, but certainly not with the quantity that we have. And then there's something that they apparently surely don't have, and that is the possibility of generating a whole story for what the future may be. So even tonight, we are involved in plans. We know what we're going to do tonight after, thank God I stopped talking and Craig stops asking me questions. And we have a plan for that. We have a plan for the next weekend. We have a plan for our vacations in summer and for what is going to continue of our lives. That is the source of this absolutely spectacular human dignity that we have, is that we have that repository of past and anticipated future that is very unique to us and that obliges us to respect human pain and human suffering and human happiness in a very particular way that is different from lots of other animals, even if there's no reason why we should not respect the animals for what they have. Okay, now I think I forgot what you really asked. But I would say yes.
I'm not about to disparage microbiology in the way that your friend did, so just hold that in mind when I ask this question. If we understand evolution as an algorithm that can operate with near complete substrate neutrality given a few constraints, then we can see that it operates on cultural units, or in other words, on culture. But the distinguishing feature of culture is that it can propagate laterally. So I wanted to ask if you think it's necessarily the best choice of words, or if it's that useful to describe bacteria as having culture rather than competence without cognition, or just cooperation without cognition, because really you are describing something that is sort of culture. It's different, and it's vertically handed down. And then because it's such an interesting phenomenon, my second question is, do you see in organisms without sort of sophisticated neurology, is there a gradient? In other words, from the prokaryotic cells, once you get eukaryotic cells, is there increased cooperation?
Okay, so I think your question is terrific. If you look at the book, you will see that every time that I talk about culture in bacteria, it's in quotes, and I take pains to say this is like. I don't go to that extreme with insects, because I think with insects we're really talking, but again, they have nervous systems, they have a lot of similarities to our organization, and the kind of structures that they produce, I think, are validly cultural. For example, architecture, systems of sewage, systems of protection, policing of a unit in a colony. All of those systems are so richly engineered. You know, I say in the book that when you really read about the life of social insects, you expect them to have invented the wheel and fire, you know, because it is so incredibly smart and well organized. But in bacteria, no. What we have is this, thanks to quorum sensing, you have an incredible richness, and you have tokens of what comes to be very important in our cultures, which is in our sociality for sure, which is the elements of cooperation and conflict. They're there very, very dramatically. But it's all in quotes, and that's why I think it's tolerable. But I think that it's worth as a strategy to make people a little bit more enlightened about the complexity of these creatures, as opposed to just dismissing them as something that one could forget. Thank you.
Thanks. I guess I have the talking stick. Jonathan Handel, I wasn't clear quite how we got from to non-algorithmic so quickly, that because of the chemical bath that affects, you know, some neurons that were non-algorithmic. I mean, I obviously accept that any algorithmic description has to be much more nuanced than simply, you know, than the sorts of descriptions we have. And, you know, an example that flashed to mind was when I was just 5 or 6, I felt a sharp pain, and I asked my mother what that was, and she very reluctantly told me that it was a bee sting, and then it hurt far more. So clearly, and you know, even just to describe the response of the organism to that stimulus, it's not just, you know, 1-0. Either there's a sting or there isn't. Right. And if that had happened to you, it might not have been as severe. So you have to start describing, you know, what is this child like? Was he a happy child? You know, et cetera. But none of that seems to me to prove that ultimately there isn't a very, very, very complex algorithm.
So here's my point. The point is about, it's not about so much algorithm, but about the possibility of predicting what is going to happen in the system. So if you're dealing with a system that is going to operate in states that are either on or off, that is remarkable, and it makes life extremely easy. But if you live in a system where the on or off are not going just to depend on the previous unit, but depend on a number of other influences, all over.
Memories and all sorts of things.
Yeah, well, but here you're dealing with a system that is not going to, in order to have the particular neuron within, for example, a nucleus in the brainstem, to have the neuron go from state 0 to state 1, you are dependent on a variety of molecules that may or may not be present and that may or may not activate it. So really the problem is with the degree to which you could, in order to model this, in which you could predict what is going to happen, given all the influences that the body is going to make into that system and other parts of the nervous system. So it's just the... by the way, I think for a long time I thought about this, and I think it's possible to do the mathematics of this. I don't have much doubt about it. The question is, practically, you're dealing with such an explosion of combinations that is it going to be useful? And is it going to give us something that resembles what we are at the level of feeling systems? And again, the issue there is that so much in what has gone on in terms of, for example, AI or robotics is not think or claim that there is a similarity to the human brain and mind, but then not deal with this critical part of the human brain and mind and overall system, which is the system of affect.
Does quantum uncertainty also add to the uncertainty of figuring out the state of this system?
That's above my pay grade. Totally. But Sean Carroll might know.
Probably not.
Okay, see, that was easy to answer.
Finally, an easy question and an easy answer.
This may be beyond the scope of the claims you're making in the book, but as you describe this ascent throughout evolutionary history of greater and greater organization from these little simple building blocks, what do you think has made evolution look favorably upon these greater and greater levels of complexity? In other words, what sort of thermodynamic work are we as individual organisms capable of that prokaryotes weren't, or are our societies capable of that we aren't, that seems to lead evolutionary history to allow more and more complexity to proliferate? And I just want to tack onto that. Do you think your conception of feeling can be transposed to super organismic systems? In other words, do you think there can be a scientific account of the feeling of a culture at a given moment, or of waves of emotion through a population or something like that?
That's very interesting. I don't know that I can deal with the last one without some more time to think. With the first one, I think that the success is so spectacular. So you increase the complexity, you increase the possibility of controlling the environment, and you generate something that is truly history, and you create huge benefits to larger and larger complex organisms. So you have the two things going on at the same time. On the one hand, the organisms get more complex, bigger, and we certainly have bigger brains, for example, and that pays off because you operate more richly with this combination of tightly run homeostasis, feeling systems, driving incredibly complicated cognitive apparatuses, and this huge capacity of creativity that in turn makes all the lives around survive better. And so you really have an increase in aggregate homeostasis, and you have an enormous increase in the benefits for the groups. I think that actually one of the things that is interesting, which is a question that I pose at the end in, I think, chapter 12, I think, is this. Given the fact that our social groups have, social-cultural homeostasis has largely operated very well for relatively small groups. Clearly, it must have begun around families and tribes of a limited amount. And then it has been extended more and more to deal with larger groups. In fact, I think one way, maybe Craig should address this, one way in which we can think about what is happening historically is that the circles of homeostatic concern have increased. And when that happens, you really come to a point where we're now dealing with the homeostasis of a culture, a cultural group, the homeostasis of a country or of a geopolitical bloc. And that's when things may go awry, because suddenly the systems that operate according to a biology that was designed in selections to fit a relatively small group of individuals is now being asked to operate at a huge number of individuals. And I think that that's a question that I ask, and I pose the question, could it be that when you have such a large number of individuals, the thing starts to fail? And the answer that I give is that if that is so, then our only possibility of salvation is through massive educational systems that would compensate for the weaknesses of the biology. But then, of course, you have to ask the question of who decides on the educational systems and on who does that massive effort. It's fine if we're talking about our culture that we regard as good, or different if it's a different group. Thank you very much.
Okay, Bonnie took my microphone away, so I'm not going to try to answer that question. Don't bring it back.
But Craig doesn't need, because he has this, this huge Helden Tanner chest.
So Antonio often tells me I went into the wrong career and should have been opera. But let me note something about what Antonio just said, though, which is there's a scale component, but you also stress in the book the way in which emotion is more than merely feeling, that it's different. So you want to define and use these terms in a way that many people fail to do, right? Who collapse all feeling of the kind you
Can I just tell them one word of goodbye? The word of goodbye is this. When we talk about emotion, the very root of the word is telling you something. It's about movement. So whether it's bacterium moving, or by the way, you can have a bacterium under the microscope, and if you have a way of poking the poor creature, the creature will recoil like this, okay? And if bacteria are in areas where there's a lot of nutrients and the climate is good, the bacteria relax, okay? All of this is very interesting because it's movement in the body that has been extremely conserved, because we still relax when we are in a good environment, and we still recoil if you have bad weather or people that attack you.
And the question is partly what they're saying. Nations, these very large-scale beings, do the same.
That's a very good question, but feeling is different. Feeling is about the mental experience of what is going on in your darn body when you are having an emotion. Period. And don't confuse feeling with emotion, although I know it's a losing battle. I've only been saying this for 20 years, and people still talk about emotions and feelings as if they were the same thing. They're not. Bacteria have emotions but not feelings. We have emotions and feelings because we can get the experience of what it is like to be in an emotional state or to have our homeostatic state.
So I want to give Antonio a chance to say that. We're getting close to the end of time here. Is there a last question that will move us? Yeah. Stephen?
Yeah, in several of the questions and answers, you've circled around this, but I just want to put it directly. In the origins of human culture, you can see the function of homeostasis. You gave us examples. In the issue of sociality, one could imagine a scale at which it no longer functions. I guess I'm asking is, at the higher reaches of the complexity of, say, operatic culture or whatever, higher mathematics, let's take, do you think there is still a remnant of that origin in the homeostatic flourishing of the individual, or can one take one's leave of that altogether?
Beautiful question. I think it varies with the area. I think there are. I think in many examples, at a certain point, it doesn't make any difference how it started. It's now an entirely autonomous phenomenon. But in some of them, there's always a residue. I think, for example, I'm just venturing that, for example, in the arts, there's more residue than in the sciences. So in the sciences, you can get to a point where you're no longer connected to the roots. In the arts, I think you're probably closer for a longer time in the development. But this is just, it's very important. I have to give a talk on that subject in 2 months, so I'm going to think about that. Thank you, Steve.
Thank you.
Okay. Thank you all. It's been terrific to have you. It's been terrific to have you engaged with and conscious of Antonio. Antonio, thank you.